All right, so let's start with our notes. We are looking at the continuous compound interest. So, last class we looked at when we when it's compounded like monthly, then that's 12 times a year. Weekly, 52 times a year. Continuous compound interest is saying that it's continuously compounding. We saw also the more times it's compounded, usually the more money that's earned. But let's see. Continuous and compound interest, this is the formula that you'll use. So anytime it says continuous, this is the formula to use. The problem says Jasmine invests $2,658 in a retirement account with a fixed interest rate of 9%, compounded continuously. What will the account balance be after 15 years? So, in this formula, you see P-E-R-T. So, P, R, and T are variables. E is an actual number. I like to compare E to like pi. Pi looks like a variable, but it's actually an irrational number. E is the same thing. It's Euler's number. It's a constant, 2.7182 on forever. So your calculator will recognize the E. So when you are typing your problem in, you can just put the E. So to find how much will be in the account after 15 years, what we'll do is substitute in. P, your initial investment. What did she invest? $2,658. E, R is 0.09 times your T, which is 15 years. This is in the packet from last Tuesday. It should be continuing where we left off. I don't have enough for everyone, like to have a second one. So see if you have it. So now you would type this in. So if we, I'm going to try to pull up Desmos, and we can look at how we would type this in. So we would have 2,658, and see, you just type in the letter E, and it'll do that for you. Now, when you do your exponent, you are going to want to put it in parentheses so that it keeps the 0.09 and the 15. So what you see is that after 15 years, the account will have $10,253.04. So, that would be equal to $10,253.04. So our statement could be after 15 years, Jasmine's account will have $10,253.04. Okay, did you find it?
No, this one.
All right, come on. All right, so that's, if anybody else comes in, I'll have to print more. Okay, so now we're going to look at a couple examples from the homework, and then we're going to move on to today's lesson. Like I said, this is the lesson we were supposed to do Thursday, so I'm not going to do all of the homework, but we'll do a few of them and then move on. Okay, so number one says you invest $5,000 for your grandchildren at their births in an account that pays 9% interest, compounded monthly. So this doesn't say continuous, this says monthly. So that tells me 12 times a year. How much will be in the account when they turn 18? So T is 18. So you can go back and find your formula. So the formula for this is A of T equals the initial investment times 1 plus R over N raised to the NT. And we would substitute into our 5,000 times 1 plus 0.09 over 12 raised to the N, which was 12, times T, which is 18. And you would type all of that in your calculator and find that you get $25,113.19. So the statement could be my grandchildren would have $25,113.19 for their college education. Okay? Now, looking at number 2. It reads, you invest $10,000, so your initial investment is $10,000 at your grandchildren's births in an account that pays 8.5% interest, compounded weekly. So how many weeks are in a year? 52. So N is 52. How much will be in the account at age 55? So setting this up, and what I will be looking for is that you can set this up. So you must be able to write out the formula with putting your numbers in the correct place. And our time is 55 because we're not doing college. We're doing, yes, ma'am.
On the tests, will you give us the formulas?
So you'll have a formula sheet, but when you read the problem, you'll have to know which formula goes with that problem.
Okay.
So we'll talk more about that. Like once we've done all of the different formulas, we'll talk more about that. So then you would do your math and find that we get $1,068,240.67. So to get full credit, if this was a test, you would have to make a statement. We have 1,060. Is it 68? Did I write 68? Yeah, 68,240.67 at retirement. I guess the grandchildren do, not we. Okay, so we'll look at number 3 and number 4, and then we'll go on to the next lesson. So number 3, this one says at age 30, you invest $15,000 for your retirement in an account that pays 8.5% interest compounded continuously. So when you read the continuously, that should let you know we are using the formula we've learned today. This is the continuous compound interest formula. If the fund is for retirement at age 60, how much will be in your account when you're ready to retire? So we didn't start putting the money into our account until 30. So our T is 60 minus 30. Now, we plug in. 15,000 is our initial investment. E is a constant. And then R is our interest rate of 0.085 times the number of years, which is 30. Again, I'm going to show you because we just learned this today. If you type that in, you're going to have 5,000 E. And when you put your exponent in, you want to put it inside of parentheses. So that's 0.085 times 30. Oh, it was supposed to be 15,000. Sorry, because that makes a big difference if we only have into our total account. So now that's $192,106.56. So we will write that and then make our statement. So that was 192,106.56. And this is how much money we have at retirement. After 30 years, I have $192,106.56 at retirement. Okay. So the last one we're going to do on this page is number 4. And then I'll encourage you guys to do 5 and 6 on your own. So 4, you invest $5,000 at a 9.8% compounded continuously. So the continuously lets me know I'm going to be using the formula we learned today. How much will you have as a down payment for a car 6 years later? So we're looking at 6 years later. I put $5,000 in the account, 0.098. And like I said last class, I really would love to know where they're getting these interest rates because they're great. So now we are, you would get that we have $9,001.92. So after 6 years, I have $9,001.92 to go toward a down payment. Okay, so you can do 5 and 6. If you have questions about it, you can email me or ask me Thursday. Okay, next in our packet is amortization worksheet. So now, what we've looked at before is us earning money. Now, this is us paying off debt. Not as much fun as earning money. This is paying it. So, we're looking at paying off a debt by making regular payments over a set period of time. For example, a home mortgage loan, the principal which is the price of the home, minus the down payment, plus the interest to be collected by the lender, is divided into equal payments, usually over 10, 20, or 30 years. Honestly, now what you see a lot of times are a 20 or 30 year mortgage. Personally, I haven't ran into an offer of 10 years, but it might just be because I wouldn't be able to afford a 10 year to pay it off in 10 years. So 20 and 30 are very common. So a portion of the payment each month goes to pay off the principal, and another portion pays off the interest. Early in the loan, most of the payment is interest. As the months and years go by, less of the payment is interest and more is the principal. So what that's saying is they're getting that extra money first. So a lot of times when you make, like I know when I was you guys' age, I bought a car, and when you pay for your car payment, the most of your money the first year or two goes towards interest. However, if you want to pay extra, you can mark on there that you want it to go towards the principal, and that way you're likely to pay your car off faster. Whereas if you just tack on extra money, usually the loan company just puts it in to and as like a blanket cost, and it covers interest and principal, so you're not working towards actually paying the price of the car off faster or as fast as if you put it all towards the principal. So this formula can look taunting, right? It's got a lot of fractions in it, but if we just take it slow and make sure you put everything in correctly, it's not as overwhelming. So let's look at what each piece represents. Okay, so we have R is the amount of your payments. L is the amount of the loan. The little r is the interest rate. That's nothing new. N is the number of compound periods. T is the number of years for the loan. Okay, so this first problem, it says, suppose you wish to purchase a house that is priced at $230,000. You have $30,000 for a down payment, and you'll borrow the $200,000 from the bank at an interest rate of 0.08. The bank will agree to either a 20 or a 30-year mortgage and will require monthly payments. What will the monthly payments be under each option? Okay, so let's look at a 20-year payback option. So notice I put why did I put $200,000 in for the L if the house costs $230,000?
Because you have a third of it down.
Because you've already put $30,000 down. So the actual loan is only $200,000. Okay? Now, the R is our interest rate. N is the number of compound periods, and it says we're making monthly payments, so that's our 12. The N also is going to be 12 down here. And notice here we have a negative 12 times 20 because the 20 is for 20 years. Now it tells me here what it's approximately. However, I want us to actually type this in. So if you have access, I want you to try typing this in with me. So we have in the numerator 200,000 times 0.08 divided by 12. Then in the denominator, 1 minus parentheses of 1 plus 0.08 over 12. And you're going to raise that to the negative 12 times 20. So if you practice typing this in, now notice if I forget my parentheses when I'm doing this, and I go up and I say negative 12, and I hit that times 20, it didn't keep that in the exponent. That's why I encourage you to put the parentheses, okay? So definitely practice typing some of this in before you have to do it on your own. Okay, so with the 20-year payback, this is how much you're going to pay per month. Now, that's not the total you're going to pay back. That's your monthly payment. So over 20 years, how much will we have paid back? So we would be paying this amount every month for 20 years, which is, it's right here too, but I wanted to show you where those numbers came from. And so this is how much you will have paid total. $401,491.20. You paid over double of what you took a loan for. Isn't that wild? Like at the end of 20 years, you've paid the bank $400,000. They only gave you $200,000. Now, what about if we did 30 years? The only number that's going to change here is the T. The only number that's going to change is the T. So in Desmos Truly, the only thing we're going to change is the T. And in this case, our monthly payment is, what do you notice about our monthly payment? The monthly payment on the 30-year mortgage, it went down, right? So if we look at that, we're probably like, ooh, give me the 30-year mortgage because I'm paying less money. Who thinks that? Who's like, this is less money, this is best? Why? It went down $200. That's a lot of money.
For 10 years?
For 10 additional years. Let's see what would happen if I take the monthly payments times 12 months times 30 years. At that point, I've done added $128,000 or $126,000 more to my price. Now I've paid the bank $528,000 and they only gave me $200,000. So why might someone though do a 30-year mortgage? Because sometimes that's the only way we can afford it, right? Sometimes we can't afford the extra $200. However, looking at this, if you can afford it, it's probably worth the lesser months, the lesser years, because you save so much money. Okay, now let's see the result of financing with a lower interest rate. So what changes in this problem for the 20-year loan option is instead of having an 8% interest rate, we're looking at a 5% interest rate. So the lower the interest rate, it should, common sense wise, we'll think my payment's going to be less. I'm going to pay less. So that's why people get so bogged down about interest rates. And they're like, ooh, I want the lowest interest rate. Because if you see here, when I have a 5% interest rate, my monthly payment went down over $300. And that's meaning it went down $300 and I didn't change anything about how I'm paying it. I changed how much money I'm giving the bank. So then when you multiply that times 20 and times the 12, if the lower interest rate, we only paid the bank 84,000. Well, no, we paid the bank $116,000 instead of the $200,000. So the lower the interest rate, the less money you're paying in interest, the less money you are basically giving away. All right, so let's look at this example. It says you want to buy a car and you have determined that you can afford to make $425 a month payments for 60 months at 7.5% interest. What is the most expensive car you can buy? So, we have right here, it showed how we set this up. But we have to figure out how we can solve for that L. So, how can we solve for the L here? So what I would do is I would find what this is, and I would find out what this is, and I would set up my problem. 425 equals, so 0.075 divided by 12. 0.075 divided by 12 is 0.00625 L. Divided by, now that denominator there, I'm going to, in Desmos, it would be 1 minus, let me go to, hold up, 1 minus 1 plus 0.075 over 12, not 120, raised to the negative 12 times 5. And so that gives me 0.3119. 0.3119. So now we can solve this for L. To solve it, we would multiply both sides. And so 0.3119 times $425. Now divide by the 0.00625. Divide. And I get 21,209. When I did it in my calculator, I got 0.20 would be the loan. Your cents will probably change a little bit depending on how much you round. So, but that tells me that that's the largest, that's the most you can spend for a car, unless you have a down payment. Okay? So, let's look at doing a couple of these problems together. And then also we do have one more lesson to look at today. And I know this class is a little bit longer because we did miss the last one. Okay, so looking at a homework problem. It says you're going to buy a $165,000 home with a down payment of $15,000. What are your monthly payments if the interest rate is 7.5% for 30 years? So first, let's determine what the L is. How much is the loan going to be? All right, I heard 150,000. How did he get that?
You subtract, 165,000 from 15,000.
Right, you subtract the down payment because you're not going to have to take a loan out for that. So we know our L. So when I'm setting this up, I know 150,000. Now, what's the interest rate? What's the lowercase r? Yep, 0.075. N is how many times you're paying a year. This says monthly, so N is 12. Divided by 1 minus 1 plus 0.075 divided by 12 raised to the negative 12 times 30 years. The T is 30. I will have to see that. I will have to see where you set it up. Then you can type it in. Again, I encourage you, even if you're not practicing typing it in today with me, I encourage you to type it in at some point so that you have the practice. Because you want to make sure you keep the parentheses in the right places. I make a big deal about this because I see people each year put parentheses in the wrong places or just not put parentheses, and then I see that we don't get the right answer. So now it shows me that the monthly payments would be $1,048.82. So $1,048.82. So your statement, you're going to have to write your own statements on a test. Your monthly payments will be approximately $1,048.82. Okay, now part B says, what are your monthly payments if the R changes to 0.07 and your T changes to 15? So that would be $150,000 divided by 0.07, still 12 monthly payments. 1 minus 1 plus 0.07 divided by 12, negative 12 times 15. So notice what changed here was my interest rate went down, which would make my payment go down. But now we're decreasing the years, so that'll make my payment go up. Yes. So we would type that in, and we find that my payments are $1,348.24. Now, while that may seem like, oh, well, it's more, in the grand scheme of things, you'll pay a lot less because you're making less payments at a lower interest rate. So it says compare the amount of interest. Yeah, that's a negative 12 times 15, sorry. Compare the amount of interest that you paid in Part A to Part B. So first of all, we need to determine how much interest did we pay. So, if in Part A we paid $1,048.82 for 12 times a year for 30 years, that means I paid $377,575.20 was what I paid for the loan. So for the interest, I take what I paid and subtract, put the 0.20, and subtract what the actual loan amount was. And so what we see here is this number is quite large, and that's how much interest you paid for your house. That's the interest. Now, that is it for the 30-year mortgage. Now, what about for the, 20 years? 15 years. The next one was 15 years. So, for the 15 years, each month, we paid $1,348.24. We paid that for 12 months for 15 years. So we ended up paying $242,683.20 paid for the loan. Now look at that. We paid the entire loan for not much more than the interest in Part A. So now, how much was the interest for the 15-year loan? We would say, okay, well, what did I pay? I paid $242,683.20, and I subtract the $150,000 that I actually, put too many zeros, that I actually, took the loan out for. Doing that, I see I only paid $92,683 in interest. So, if we see, so how much more interest did we pay in the first option? The first option, we pay
$77,575.
I got 134,000 less. When I subtract the two interest amounts, the 30-year mortgage costs us approximately $134,892 in interest. And truly, you could subtract the total loan amounts and find the difference. But I did want you to actually see that number for the interest. All right, so let's look at number 2. Number 2 says you want to purchase an automobile for $31,000. with a down payment of $4,000. What are your monthly payments if the interest rate is 8.5% for 72 months? How much interest do you pay? All right, so we want to find out what the monthly payment is, the total of your payments, and then we can determine how much interest we pay. So, L, how much is the loan? The car's $31,000, but we're putting $4,000 down. So the loan is only for $27,000. Now the R is 0.085, and I will say this is a high interest rate for a car. Over 12 monthly payments, especially if you're buying a new car, a lot of times you can find new cars with 0% interest. What? Well, my car right now has 0% interest for a 5-year loan from the Honda dealership. Now, I will say, so I bought my first car when I was like, I think 19. And I was, in my head, I'm like, okay, I'm 19. I only worked part-time because I was going to college. And I was like, I can only afford this. So I was like, I'll need to get a used car. And the guy at the dealership told me, he said, well, actually, the interest rates are better on a new car. Usually, because the bank feels that you'll keep that car longer, so they give you a lower interest rate because there's less likely to be issues with the vehicle. So I was like, I don't know. And so he ran the numbers, and I was able to get a new car with a lower interest rate for only like $20 a month more than a used car, because the interest rate for a used car was like 8% and a new car was like 2%. But probably if I want a math person, he might could have. But I knew, I was like, let me run these numbers myself.
I'm glad you did, because that went crazy.
And so, like, since then, like, my mom has gone to buy a new car, and she's looked at, too. Now, sometimes there's not, if the interest rates aren't that good, then it's, now, I couldn't have got a brand new, like, luxury vehicle cheaper.
That's still a good car.
It was, and I still drive it onto this campus today, so pretty good purchase if you ask me. 2009 Honda Civic. Yep, it does. And driving it around. The paint might be peeling, but we here. So when we do that math, we get the payment is $480.02. That'll be the monthly payment. So now, what's the total of all of our payments? We would say $480.02 times 12 months for 6 years. And when we do that, we get $34,561.44. So, how can I find out how much interest I paid? You want to take the total minus the loan. The total minus the loan. So for the interest, you would take the total minus the loan. So now, 34,561, subtract the loan. So with that high of an interest rate, you paid an additional $7,000 for that car, which is pretty high for a car. You also have to think about with a car, when you take out a loan, the longer you take out the loan, the longer you're paying on that car, and some cars don't last that long. You get what I'm saying? Like, if you take out a 7-year loan, what if your car doesn't even make it? You're still paying on that car, and you don't have a car. So the shorter you can take out a car loan and afford it, in my opinion, is a better deal. Especially if you're getting a used car, because it already has some miles on it, literally. So, right. Well, yeah, that's obviously the best deal. So, after 72 months, you will have paid $34,561.44. And that includes $7,561.44 of interest. Okay, so I'll leave number 3 solving for L. So we should probably do that. All right.
Can you go for a quick second?
Yep. So for number 3, we're going to be solving for L. So let's do this. A loan company has determined your debt ratio is such that you can afford house payments of $1,350 per month. If the interest rate is 7.2% for 15 years, what is the price of a home you can purchase? So this would be 1350 equals L times 0.072 divided by N, which is you're making monthly payments, divided by 1 minus 1 plus 0.072. And truly, that's 7.2%. You see how that has the decimal, like random decimals? That's pretty normal. That it would be, you're not going to usually get a 2% interest rate. It'll be like 2.7 or something, which today it's not going to be 2.7. I think right now home interest rates are between 6 and 7%, and that's considered good. When I bought my house, my interest rate was 2.5%. So a lot higher now. So we want to find what is this. So in a calculator, 0.072 divided by 12, 0.006 L divided by, now I want to do this denominator. And again, if you try to do this in your phone calculator, more power to you, but I would not. Just keeping it honest. 1 minus, don't forget your parentheses, 0.072 divided by 12 raised to the negative 12 times, was it 15? Yeah. So that's 0.6593. 6593. All right, now we can solve that. Multiply both sides by the 0.6593. So 0.6593 times 1350, 890.055. And then we can divide by the 0.006. And that gives us, we can afford a $148,342.50 house. Okay, so approximately. So about $150,000 house. Now, back in the day, if something was priced at $150,000, you probably could offer $145 and they'd accept it. But nowadays, nope. Nowadays, if it's priced at $150, you're probably gonna pay $170. Like, the housing market is insane, but it's getting a little better. So we have 2 more lessons. So let me think real quick. All right, so let's look at growth and decay. Yeah. All right, growth and decay. Then I have, we need to look at pH, and I have a handout for that, and we'll look at that. Let me think. Yeah, let's go ahead and do this. All right, exponential growth and decay. The formula is here. Notice it again uses the E, Euler's number. It's a constant. A sub 0 is your initial amount. K is the growth or decay constant. T is time. All of this is within the problem. So we're going to do a few of these examples. Next class, what we're going to do is we will go over this pH sheet. And you do have a test we need to do on this. But we'll talk about that at the end.
Ms. Ford,
What?
we have a class next week.
We'll talk about that at the end of class. Let's go over this. I don't want to upset you now. So, let's go over this. All right. Growth example. A researcher is interested in the population of a particular type of frog. She studies in the frog population of a pond where this particular type of frog seems to thrive and finds that the population she is studying grows exponentially. That means they're growing fast. She finds that the population grew from 48 to 256. Give the exponential equation that describes the population after T years. Okay. So, when we look at this, what we know, well, hold on, I'm not going to write the formula right now because it's there. So what we know is that how many frogs, we know the amount after a certain number of time. How many frogs did they end up with? They ended up with 256 frogs. What was the initial amount of frogs? What? 48 was the initial amount of frogs. Now, the K is the growth or decay constant. That is what we're going to be looking for. Do we know the T? Do we know the time? How many years had passed? 6 years had passed. Let me pull up Desmos on my phone. 6 years have passed. So, what we want to do is solve for K. I'm trying to get my Desmos to pull up.
Wait, is 6K or T?
It's a 6K right there. 6 is your T.
Okay.
Here we go. Trying to get this typed in. All right, so there are multiple ways